Alrighty, folks, we're going to look at some sample questions that you might have to do about axis of symmetry and x-intercepts, although we're going to show you a way around one a little bit, okay? So, finding axis of symmetry from a graph, from a table of values, and from an equation using a symmetry strategy. So here's our first question, multiple choice. What is the equation of the axis of symmetry for the function represented by this given table of values? Okay, whoops, jump back there. So for this, remember what we did in the instructional video here was we went after the x-intercepts. So if those are our x-intercepts, we see that we've got x equals -1 and x equals 5. So if those are your x-intercepts, then your axis of symmetry should be at the average of those two numbers, -1 plus 5, divided by 2, which is going to give us 4 over 2, or 2. So x equals 2 is our axis of symmetry. You could also have noticed the nice symmetry in the pattern here. And if you look at the y coordinates from the table, then you see 6, 0, -3, -3, 0, 6. So the parabola goes down and then it goes back up. And you can see right in the middle there you should have your vertex and your axis of symmetry halfway between 1 and 3, which is, yes, indeed, at 2. Okay. This one's a bit tricky. I'm going to show you two different ways to do this. It says, what is the equation of the axis of symmetry for the function given by that stuff? Let's do it the funny x-intercept way first. So the factoring strategy that we're supposed to be learning, even though we really haven't found out how to solve equations to find x-intercepts yet, that's what makes this a bit funny to do it now, but you can always come back to it later. So it was a common factor strategy. We took out a common factor, 3x, and that left us with x plus 4. Okay? So that gave us, we said, either 3x must have been 0 to make that stuff equal 0 when it's multiplied, or x plus 4 is 0. So that means that x would have to equal 0, or x would have to equal -4. Make x's, not y's. Okay, so if that's the case, then we can get our axis of symmetry by taking the average of those, 0, and then plus a -4, divided by 2, which should give us a -2. Okay, so there's our axis of symmetry for this. It's at x equals -2 if we do it that way. I can't imagine that you would ever be given a test or an exam question that would say, determine the axis of symmetry for this particular equation in standard form by first finding its x-intercepts and then averaging them. That's a bit weird, and we already know a really good way to find axis of symmetry for the equation when it's given in standard form, which is what we have here. This is a standard form with a equals 3, and b equals 12, and c equals 0. Okay, and if you remember, the axis of symmetry in standard form is always at x equals -b divided by 2a. So if that's the case, we've got -12 divided by 2 times 3, which is -12 over 6, or -2. And that's exactly what we said it was in the more complicated way. Okay, so even if you're not going to take this method away as a sort of bona fide way to find your axis of symmetry or your vertex or whatever, it is a nice thing, though, to see the relationship between the x-intercepts and the axis of symmetry. I think it's particularly nice to see when we look at a table of values in a graph. So just remember that we can find the axis of symmetry for any parabola using the x-intercepts and the properties of symmetry. It has to be halfway in between those. So from a graph, we simply determine the x-intercepts and find their average. And from a table of values, we can do exactly the same thing. And that's really the most important new thing here that you may not have realized from a table of values. Look at where y is 0, find out those 2 points and average them. Bingo, you've got your axis of symmetry. Okay? From an equation, we can determine the x-intercepts and find their average as well. Yep, you can do that. But as we said earlier, if you have the equation in standard form already, the other formula is much easier. So I'd probably recommend that you go that way. Okay? So and when it's not easy, you can use that partial factoring strategy if you wish, and if that's what your teacher is going to do, go for it. Good stuff. It's not a bad way to do it, it's just different. All right, good luck. Hope that's helpful.